And we see much more nickel than iron, which is very unusual and maybe implies industrial production of nickel.
The warning does not arrive as a siren or a flash in the sky. It arrives as numbers that refuse to stabilize. Orbital calculations update, then update again, each revision confirming the same reality. Comet 3. Why Atlas is already inside the solar system, and today it is closer than it has ever been. At roughly 170 million miles from Earth, astronomers confirm what they hoped would not be true. This object did not form here. Its trajectory does not loop back toward the sun. Its speed does not match local debris. It is passing through, cutting across the solar system on a path that began around another star entirely. The margin for error collapses. There is no historical model to fall back on. This is not a comet with a known past. It has no record, no cycles, no guarantees. As the data sharpens, the unease deepens. Spectral analysis reveals chemical signatures that do not belong to the sun's neighborhood, molecular ratios that suggest formation in a colder, older, and radically different stellar environment. Scientists recognize the implications instantly. Objects like this do not follow familiar rules. Their structure, density, and internal stresses evolved elsewhere under forces we did not observe. This is only the third confirmed interstellar object ever detected, and that fact makes prediction weaker, not stronger. 3 data points are not a trend. They are a reminder of how blind humanity still is. Every assumption built on solar system comets suddenly feels fragile. There is no certainty about how 3I Atlas will react as it moves deeper into unfamiliar radiation, gravity, and solar pressure. Around the world, observatories pivot almost simultaneously, as if responding to an unspoken alarm. Time-sensitive observation windows open and begin closing just as fast. Data streams surge, minor anomalies appear, then vanish, then reappear in revised plots. The object is moving too quickly to pause, too distant to intercept, and too unfamiliar to predict. Astronomers understand the pressure immediately. This is a one-pass event. Whatever is not measured now will be lost forever. There will be no second look, no return visit, no correction. As the comet continues its silent exit trajectory, the realization settles in with weight. Humanity is watching something it barely understands, and it is already slipping away. And just as the first datasets begin to stabilize, a new inconsistency emerges in the numbers, hinting that this encounter may be far less predictable than anyone expected. It does not flash, it does not roar, but the world reacts like something just exploded in the sky. Comet 3. I-Atlas is not a threat by trajectory, and yet the panic is real. The obsession is real. And it begins the moment scientists realize something they can't explain. This object is not large enough to be dangerous. It is not bright enough to dazzle. But it behaves like a needle through human certainty, threading together fear, wonder, and something worse, silence. Because 3I Atlas is not just an object from another star system, it is the first one to come this close, this measurable, this present. Astrophysicists scramble to stabilize telescope arrays as the object crosses a crucial detection boundary. Spectral readings flood in, not confirming anything, but unsettling everything. A strange ratio of carbon isotopes shows up, ones that do not occur near the sun. This is not just foreign, it is chemically outsider. For the first time in years, space scientists cancel conferences mid-session. Public streams of the comet's trajectory hit millions of views in hours. This is not like Oumuamua. This is not like Borisov. 3I Atlas has momentum, not just in space, but in the human psyche. News anchors say it broke containment. What they mean is it left the hands of specialists and entered the bloodstream of culture. Artists paint it. Children ask about it. People go outside hoping to feel it. But the scientists don't share the excitement. They feel something colder. Every headline makes it sound like awe. But behind closed doors, researchers talk about behavior. The comet adjusted spin slightly after crossing the asteroid belt. It began releasing volatile gases, not in uniform plumes, but in irregular jets, as if something inside it had pockets of pressure waiting to burst. A theory circulates, then gets buried. The object might not be a comet at all. Not entirely. What if it's a hybrid? A class of body the solar system has never encountered. One that mimics comet behavior but was formed under physics we've never studied. The urgency is no longer academic. Governments quietly ask for private briefings. Funding for observational programs triples in a week. A telescope in Chile is granted 24-hour priority access without public notice. Why this object? Why now? That's what unnerves even the most grounded scientists. Because the obsession isn't just public, it's planet-wide. Even those who don't know what it is feel like something is about to happen. But it's not brightness, or speed, or size that haunts them. It's proximity combined with origin. A traveler from another star, passing close enough to read and perhaps close enough to hear. Because some low-bandwidth receivers detect pulsed interference, not radio, not cosmic noise, just something that shouldn't be there. The comet doesn't speak, but it isn't silent either. And the closer it gets, the less anyone is able to explain the reaction. Worldwide attention builds not because of what the object is, but because of what it feels like. As if something is trying to get through. As if something old just remembered us. Something's wrong, and everyone studying 3I Atlas knows it. In a darkened lab at NASA, astrochemist Stephanie Milam stares at the latest spectrograph. The data doesn't fit. The chemical signatures pouring in from the object match nothing known to Earth-based formation models, not even close. One spike resembles formaldehyde, but warped. Another hints at carbon chains never recorded in the solar system. These molecules didn't form near the sun. They couldn't have. She scrolls through atmospheric readings, whispering, "It's not from here." And that's not poetic. It's literal. Across the country, astrophysicist Hakeem Olusei watches the trajectory plot shift again. The object is deviating, slightly, but repeatedly. It's not behaving like a dead rock obeying gravity. Something is altering its speed and spin, subtly and unpredictably. Solar radiation pressure can't account for it. Not fully. "This isn't random drift," he says during a late-night briefing. "It's showing resistance to expected forces." Silence answers him. Every previous model struggles. Known comet behavior breaks down under this anomaly. Ice outgassing? Unlikely at this range. Fragmentation? No debris cloud. Magnetic interaction? Still too weak. What's guiding it now is unknown, and that's the problem. 3 interstellar objects have ever been confirmed by human eyes. Oumuamua, Borisov. And now 3I Atlas. 3 is not a trend. 3 is a warning. A whisper that detection is the exception, not the rule. Stephanie reruns older scans from just 10 days ago. Even they don't match today's readings. It's changing. Fast. Too fast for comfort. The object's surface appears dark but oddly warm in infrared. That breaks thermal logic. Some believe the crust is thinner than it should be, possibly cracked. Could there be subsurface material releasing invisible particles? What happens if the object vents, or worse, splits? If that happens, no one will know until it's already too late. The comet is measurable but not predictable. Every certainty dies the closer it gets. Stephanie finally looks up from the monitor and asks the question no one wants to hear. What if this isn't the first one like it? Just the first we noticed? She doesn't wait for an answer. Because something even stranger is about to appear in the data. The fear begins where the data ends. Every telescope trained on 3I Atlas reports one truth. It is leaving, fast, and it is not coming back. Inside the darkened control room of a European observatory, the live trajectory feed stutters. The object has shifted slightly, but enough. Enough to throw off a model that had just stabilized hours earlier. A senior astrophysicist leans forward, heart ticking louder than the machine's. He whispers a question that freezes the room. Did something push it? No one answers. No one knows. Around the world, labs scramble to verify the anomaly. Minor thermal variations were expected, but this change in angle, barely a fraction of a degree, isn't consistent with outgassing. It's too fast, too smooth, and it doesn't spin the way it did 3 days ago. That's when the quiet fear creeps in. What if this isn't the first time? What if 3I Atlas is just the first one we noticed behaving this way? Scientists stop asking what it is. They start asking how many like it have slipped past unseen. How many came and left carrying secrets we never had the tools to detect? The realization lands hard. Earth's detection capability is embarrassingly narrow. Objects like this could have passed silently for centuries. Maybe they still are. Archived sky scans from 10 years ago are reopened and reprocessed using new filters. And in a grainy corner of a 2014 dataset from Chile, something flickers, faint, angled, fast. It matches no known orbit, a second possible interstellar object, or something else. Teams are now working in shifts, terrified to miss even a second. There's no margin for delay, no second pass. Every minute 3I Atlas moves deeper into the solar system's exit corridor, its speed accelerating with no clear gravitational reason. The pressure becomes unbearable. Every incomplete dataset feels like a crime, a once-in-a-lifetime chance, evaporating with every frame. There is no precedent, no protocol, no pause button. And above all, no certainty. Every camera follows a ghost. Every sensor trembles at the edge of failure because in interstellar astronomy, there is only one truth. When the window closes, it slams shut forever. And that's when the next anomaly appears. The clock is ticking, but not just for 3I Atlas. Far above the planet, another countdown moves in silence, one far more human. The International Space Station, our most iconic symbol of global cooperation in orbit, is nearing its final days. Plans are underway to crash it into the ocean in a controlled descent. No rescue, no preservation. Just a quiet burial in salt water. Engineers already refer to it by its final coordinates, Point Nemo, the spacecraft graveyard. But as telescopes track the foreign visitor from beyond the stars, a question grows louder in the minds of scientists and citizens alike. Why are we letting our own creation die just as something alien arrives? 3I/8 streaks past Earth, carrying molecules never before seen near our sun. Some of those molecules, highly volatile carbon chains, should have broken apart near any star, but they haven't. They're intact, stable, and that's alarming. Infrared arrays detect rapid fluctuations in the comet's outgassing, as if it were reacting to solar radiation differently from any comet previously observed. Its tail shifts direction inconsistently, sometimes against the solar wind. A subtle electromagnetic distortion is logged, first dismissed as instrumentation error, then confirmed by 3 separate observatories. Something around the comet is interacting with Earth's magnetosphere, however faintly. And in the middle of this discovery, we are preparing to destroy our only orbital science station? The timing feels cursed. While something alien approaches with unexplained signals and unclassified chemistry, we are erasing our own capacity to watch it up close. A satellite array meant to record deep space phenomena was mothballed last month due to funding. The observatory in Chile lost power for 6 hours just as the comet passed its closest point. Everything seems to misalign, as if reality is leaning away from explanation. Is this cosmic irony, or a larger blind spot in our priorities? Some whisper that we are dismantling the wrong things at the wrong time, that the overlap between 3I Atlas's arrival and the ISS deorbit isn't coincidence but consequence, evidence of a civilization underestimating its moment. As the comet turns outbound, cameras aboard the ISS film its fading trail for the last time. The footage cuts off mid-transmission, not because of failure, because the crew was ordered to switch systems, and just like that, the most iconic structure in orbit will fall, while an interstellar object slips away with unasked questions still burning in its wake. But one final anomaly is logged as the station prepares to shut down. A signal, weak, unclaimed, patterned, detected on the deep space array, bouncing back from the trailing end of 3E Atlas. It carries no known language, no typical pulsar timing, no gravitational lensing distortion. It pulses 13 times, then stops. No one knows what it means yet. There will be no sirens when it vanishes, no light trails, no final signal. Comet 3. I-Atlas will simply slip past the outer edges of the solar system and disappear, silently, permanently. But the fear doesn't begin after it's gone. It begins now because we still don't fully understand what just passed us. In observatories across the globe, teams are working without sleep, analyzing spectral data from its coma. But what they find only deepens the mystery. There are traces of molecules no one expected, chemical signatures that shouldn't exist in known cosmic chemistry. One scientist compared it to finding seawater in a desert cave miles from any known ocean. The object's trajectory wasn't smooth either. It jolted slightly, almost imperceptibly, as if reacting to something. No gravitational body nearby, no heat burst, just a sudden deviation, like a reflex. That moment is now being called the flicker event. What caused it? No one knows. And that silence is more terrifying than any sound. Astrophysicist Dr. Hakeem Oluseyi admitted in a closed session that this object was not behaving like a dead rock. That sentence leaked. It went viral in scientific circles. Some fear the comet may have passed close to something undetected, a dark mass, a rogue influence. Others are asking if 3I Atlas was even alone, if this was a vanguard, not a stray. Because here's what terrifies them most. If 3I Atlas passed this close, what else has passed? What else is passing right now? The sky is not empty. It never was. We only just got good enough to notice one, and it's already leaving us, with no return. No second chance. Every frame of data becomes sacred, every spectrum a relic. In the silence that follows, the world is left with one impossible question. Did we just miss something we were never meant to see? And then, just as scientists begin to archive the final inbound readings, a signal pings at the edge of a deep space radio telescope in Argentina. It's weak, patterned, not from Earth. And it's coming from the same direction 3I Atlas came from. The signal lasts 9.3 seconds, then vanishes. No one knows what to make of it yet. But a new alert is quietly triggered across research networks.